Let's begin. Today's May 13th, 2024, and we're doing the Daily Turing Machine Puzzle. Notice that today's puzzle uses 6 criteria cards and the 6 verification cards. Let's go to turingmachine.info to get more information about this puzzle. So again, today's puzzle uses the 6 criteria cards, and then it uses the blue verification color scheme. And of course, above we've got the unique identifier for today's puzzle. So let's go solve. So notice that we have our 6 criteria cards. We have on the top row criteria A, B, C, and on the bottom row we got criteria's card D, E, and F. So criteria A is going to look at the triangle digit, which is our first digit in our solution, and it's going to let us know whether the value of the triangle is less than 3, equal to 3, or greater than 3. Criteria B looks at the third digit, the circle digit, and will let us know whether its value is an even or an odd. Criteria C will let us know how many 1 digits are there in our solution. Are there no ones? Is there a 1, maybe 2 of them, or all of them are 1 digit? Criteria D compares the first and the second digit, the triangle and the square, and since it's comparing them, it's basically going to let us know whether triangle is less than square, is triangle equal to square, or is triangle greater than square. Criteria E basically will let us know, is there a pair of digits, a duplicate digit in our code, as in the example 131, or otherwise it has no pair. Either they're all unique, as in the example 134, or they're all the same, as in the example 222. And finally, criteria F will let us know whether the digits are increasing in order, as in the example 135, or are they descending 4, 2, 1, or potentially there is no order. Okay, so remember, our objective is to find a unique 3-digit code that meets all of the criteria above. So the first thing I'm going to test is criteria B, and I'm going to try to figure out what the third digit, the circle digit, is its value even or odd. So the Turing machine responds, no, you are incorrect. So if I look at my proposal of 314, I chose to have a 4 for circle. It's telling me, no, that's not correct. So that means that circle is not even, it must be an odd digit. So I'm going to go into my notes and write down that circle is an odd digit. Okay, so that means that I can go up here and eliminate all the evens. So it can't be a 2 and it can't be a 4. Okay, so next I think I'll test whether there might be a pair of digits. So let me test criteria E. Okay, so we got a check mark from the Turing machine. So if I go back and look at my proposal, notice that my initial proposal of 314 has all unique values. So the Turing machine approves of that. So that means that there are no pairs. I should rephrase that. It's not that they're unique potentially. Very likely they are unique. All we know is that there is no pair. So they're either all unique or all the same. So let me write that down in my notes here. So basically, there is no pair of digits. Okay, so but it's very unlikely that it'll be all the same. We'll determine that as we go along. Okay, so we've done 2 tests. We have 1 more per turn. So let's see, I've got a choice between finding out what triangle is, comparing, the size of the triangle and the square, and whether it's, increasing, decreasing, or no order. Um, let's see. I think I will compare triangle and square. So that is criteria card D. So let me verify D. Okay, so the Turing machine approves. Again, let's go back to our proposal. Notice that since we're comparing triangle and square, in my example, my triangle value is greater than the square, and the Turing machine approved of that. So that means in my notes, I'm going to write down that triangle is greater than square. So triangle is greater than square. Okay, now that doesn't mean that my triangle value is a 3 for sure or a 1 for square either, but simply that triangle is bigger. So what can we say about that? Can we eliminate any possibilities? Well, it seems that if triangle is to be greater than square, then triangle can't be 1. So it's impossible for triangle to be 1 and square be even smaller. And on the flip side, that means that we can also say that square can't be 5, right? If square is 5, then there is no digit larger than 5. So we can eliminate those two possibilities. Is there anything else? So we've established that circle's odd, triangle is bigger than square, and there's no pair of digits. Okay, so it's just time to come up with a new proposal. Now, we haven't tested what triangle is for sure. Now that we've eliminated one choice, it's either half even, half odd, but then there is that equal 3. We haven't tested how many ones there are. We know that if there is a 1, notice this, if there is a 1, only one of these can be, right? Because we're told that there's no pair of digits. So either there is no 1 or a single 1. Obviously can't have 3 anymore, and no pair. So that may be a good idea to carry over into our new proposal, that there might be a 1. And so let's see, and then there's the ordering. So what went wrong with B? So B means that this should be an odd digit. Okay. So again, we're trying to figure out what these 3 digits are. Again, one of them I am gonna use a 1. But how would I choose the other digits? What can we do to triangle and square so that maybe we kind of force circle to be something, and maybe the ordering is gonna tell us. So perhaps if we make circle the 1, can we force circle to be 1 and choose our triangle and square in such a way that it forces it? How can we achieve that? Or maybe even vice versa, making it into a 5 perhaps. So again, triangle has to be bigger. So somehow, if we choose, maybe perhaps there's no order, and so I choose a triangle that's bigger than, where triangle's bigger, then it goes smaller to square, and then greater. But there's really nothing there to tell me that. So if triangle is less than 3, that would mean it would force it to be a 2, since we've already eliminated the 1. And if it is greater, then it'd be a 2, 1. But then purple, there's nothing there to tell me whether it's going to be a 3 or a 5. So no, I don't like that. And perhaps if it's greater than 3, that would force it to be a 4. No pair here and no 5. So 4. But then what would happen to square? This is interesting. Yeah, I think I'm just going to have to, try something. And man, this is a tough one. I'm having a difficult time coming up with a good proposal. If it's 3, perhaps 3, 2, 1, 3, 1. No. I need to somehow force also square 2, 1. 3. Wow. All right. I'm just gonna do something. Let's just do 4, 3, 4, 3, 1. I'm gonna do 4, 3, 1. Okay. All right. So let me test. Let me test how many 1s there are. I do have a 1 in there, so let me see C. Okay, so there is a 1. So let me go to my notes for C and basically state there is a single 1 digit. Okay, again, doesn't mean that it's in purple, but we do know that there's a 1. And of course there's no pair, so there's only a 1. Okay, so now let's test A and see what that can tell us about triangle. Okay, so that is incorrect. So it is not greater than 3. So triangle then is either equal to 3 or less than 3. So triangle is either less than 3 or equal to 3. Okay, so if it's not greater than 3, then it can't be a 5, right? And it can't be a 4. So we can eliminate those two choices for triangle. Can't be 4 and can't be 5. So therefore, and remember, triangle needs to be bigger than square. That means that I can come up to square and eliminate 3 and 4. Wow, that's interesting. And of course, the reason I can do that is because remember that triangle needs to be bigger than square. And so as it is now, triangle is 3, so that means square has to be less than 3. So that leaves us with 2 and 1. And then let's try, so my proposal 431 is descending. So if it's descending, it literally has to be 3, 2, 1 at this point. And that's very unlikely. I mean, that is a possibility. Is there something else I could test that I'm unsure of? Well, I can't test A again in this current round. It looks like B, C, and D are already done. Well, let's do this. Let me list out some potential answers. Is it too soon to do that? Well, let's see. I've got 2 possibilities on top, 3 in the middle, and 3 on the bottom. And so that's 2 times 2 times 2, that's 4, times 3, that's 12. That is 12. That may be too many possibilities. So, yeah, so I don't think I really can test anything but F, even though there's only one possibility for it. Let me think back to circle. What will force circle to be something? If it's 1, boom, you already have it. And it could be in the descending. Otherwise, if triangle's 2, that forces this to be a 1. Okay, so here's an interesting thought experiment. If triangle were 2, that would force square to be 1. But there's nothing else to distinguish 3 and 5 for purple. So what I'm saying is, let me go down here in F, and if I were to list out that potential solution of 2, 1, 3, or 2, 1, 5. So again, if I were to choose triangle to be 2, that forces square to be 1. There's no pair, so I don't have to choose 1 for circle. And that would leave me with 3 or 5 for purple. I don't see anything in our list of criterias that'll differentiate between 2, 1, 3 and 2, 1, 5. I already have the 1. Purple is odd. And in both cases, they are without order, because it goes from 2 to 1, that's down, and then up to 3 or 5. So I don't believe triangle can be a 2. So I'm deducing that triangle needs to be a 3. Okay? So again, I don't see any possibility where 2, 1, triangle 2, square 1, where I can differentiate between 3 and 5. I don't see that. Okay, so what I'm saying then is, let me make it somewhat official. I'm saying that triangle needs to be equal to 3. And I am going to also cross out the 2. And so I'm saying that my solution so far has a 3 for triangle. Okay, so that would leave us, let me go down here, that would leave us with a lesser amount of possibilities. So that could be 3, 2, and then I'm not sure what circle could be, or it could be 3, 1. And again, I don't know what circle might be. Actually, if it's 3, 1, this is interesting. This 3, 1 is very interesting because I can't pair up the 3. I can't pair up the 1. So this would force circle to be 5. So that's a very promising solution. So for 3, 1, it has to be a 5 for circle. That's very promising. Let's take a look at 3, 2. If it's 3, 2, it could be 3, 2, 1, or 3, 2, 5. 3, 2, 1, or 3, 2, 1. Yeah, and 3, 2, 5. Can't be 3, 2, 3 because there's no pair. So 3, 1, 5, yeah, that's the only possibility. Then 3, 2, 1, 3, 2, 5. Okay, so now that I've narrowed it down to three possibilities. If I were to test F now, these last two have no order, right? It starts at 3, they both go down to 2, and then they go up to 5. So what would differentiate these two then? I don't see anything that differentiates 3, 2, 5 and 3. Oh, 3, 2, 5 is impossible. There's no 1. Yeah, there's no 1. 3, 2, 1. Okay, so it can't be 3, 2, 5 because there is no 1. Oh, that's interesting. Okay, well then that would mean that I can test F because I have either descending or no order. Okay, wow, that's amazing. I hope this does work out. So let me actually, test F. That's the only way to differentiate it. And so my proposal 431 is descending. That's what 321 basically represents. It's each digit is getting smaller. So that is not correct. So that would lead to 315. 315. Okay. So so in my notes for F, I would probably put something that's either descending, it's either descending or no order. I apologize. Not descending, ascending, because I did choose a descending proposal. So it's actually ascending or descending or no order. Okay, no pair. Okay, so 315. So let's take a look. So again, I deduced that it was a 3. So there's my 3. Circle is an odd. Yeah, 5 is odd. There is a single 1. Yeah. We do have triangle greater than square. Yeah, triangle is bigger than 3 is bigger than 1. There's no pair, and it's in, well, we deduce that it has no order because, so ascending we didn't actually test. So, okay. I hope this is not being too risky, but I believe 315 is our answer. Let's go verify. So we go to turingmachine.info, we test the code, and we have 315 just to make sure that that is exactly what I have. 315, yeah. Verify. Okay, fantastic. It really worked out. Okay, so some of those deductions really worked out. Okay, fantastic. Well, again, we do need to verify and see how we did versus the Turing machine. And so we did do it in 2 rounds. So we did BDE first. BDE. And then in our second round, we did ACF, the other 3. ACF. And how did we do? Okay. Oh, wow. So the Turing machine also did in 6. I was really hoping, I thought I'd beat it by maybe 1, maybe even 2, but we tied. It's still a win, so that's great. So just kind of to wrap things up, it really was sort of helpful to do this listing of proposals, talking through what are the possible solutions. I was worried that I would have to go to a third turn, but because I did some of this work up front and just looking at every possibility and seeing, testing out, right? You want to talk through some of these answers, potential answers, and see, hey, does it work? What, how does that affect the other digits and whatnot? And this is a good example of that working out, that strategy. So I hope when you play, you'll do that. Okay, well, that does it for today. Hope you enjoyed today's video. If you liked it, please give it a thumbs up so that other people will find this channel. And if you don't want to miss tomorrow's solve, please subscribe to be notified. Have a great one. Thank you so much. Take care.